work in applied mathematics, and specifically I work in mathematical biology, and the problems I work in involve creating models to predict genomic variants. So these are changes in your DNA and how they're passed from one generation to the next. So this could be related to certain cancers or just visual differences we see in individuals. I was always interested in genomics and biology and how math could be applied to that. And I think that's something that I didn't know about coming here as an undergraduate, but now I can share that experience with undergrads and graduate students at Fresno State. I would summarize the experience that my students get by working in my lab as improving communication, writing, as well as learning programming. For example, Python, that's the main programming language I use. And so students really get skills to not only do mathematics, but to communicate that mathematics with other people. So in addition to working on math biology, I also work in machine learning and machine learning methods for problems in biology or imaging. And so students that come into my lab meet with me regularly once a week, and they have to do presentations where they summarize things that they did, things that went well, things that didn't go well, and how they're going to address those issues in the future. So there's a lot of presenting their work and talking about what obstacles they encountered through that week. So it's a pretty regular meeting. Most of my students work independently, but some of them do work in teams. In addition to presenting to me at our weekly meetings, they will also be required to present at either local or regional or national conferences. So that's something that really enticed me when I was doing research as an undergraduate, is that I could travel and present my mathematics to other people and communicate that to other people. So that's something I still have my students do in my research group. There are no particular courses that students need to take to be involved in my research group. I do have recommendations. They should be able to bring something to the research group. So if they're really interested in the math part, then I recommend linear algebra. If they don't have experience in that, then they should have some experience with programming, or on the biology side, they should have some experience with bioinformatics, for example. As an undergraduate, I felt like there was a lot of applications for math, but I didn't really see too many. And so as a faculty now, I try to present those applications of mathematical biology and imaging, for example, to students. So if they're incoming students, if you're taking Calculus 1 or you're taking statistics, after taking those courses, you're in a position to learn more about how to use those skills in biology and how to model things that we state in biology as a mathematical problem. I would encourage incoming students also to get involved in clubs that would help improve those skills. So I'm also the co-advisor for the SIAM Club, which stands for Society for Industrial and Applied Math. And in that club, we're going to be doing programming tutorials and some workshops for programming. So if you want to build those skills, you can as well. For incoming students, consider a major in math. When I was an undergraduate, I felt like a lot of faculty told me that there were many career opportunities in math, and I still believe that, and I think there are many job opportunities where you can apply a math major that the job is not going to say mathematician. It's going to say data analyst, it's going to say accountant, it's going to say a variety of different titles, but you can use your math degree to communicate and to show that you know how to learn difficult material.